Hello guys, my name is Arun and welcome to my channel. This series is a series of tutorials on Fortran programming. Now, in this tutorial, we'll be looking at functions which can return array values, and then how to use a facility called as modules in Fortran. Now, if you guys notice, this is exactly the same program that we saw in the previous tutorial. Okay, the program that helps us to write and find the solution of a system of simultaneous equations via Cramer's rule. Okay, now what I made here is that I just made some small adjustments to it. I just included this new statement called as use maths 1. Okay, uh, now where did this come from? As this comes from this file over here. Now this is the same file that we saw last time, but with a little changes. I just made this file as a module. Now what a module is in Fortran is this. It's a collection of functions and subroutines in an orderly manner. Suppose let's say you have let's say 20 functions or 20 functions and subroutines that you like to use again and again for several purposes. For instance, this determinant function, leave this Cramer's part, but this determinant function, calculating function, and this slice subroutine might be used for many purposes. Many purposes other than solving the solution, finding solutions using Cramer's rule. Okay, now suppose if I were to make a file like this. If I were to make a file like this and use it again and again, what I have to do is that I just have to copy this content and place this again and again several places. But what if I can make this file, I can just make a copy of this file alone in one single place, and I can use it multiple locations. Okay, that will be nice, right? And besides, what if I can group them together, group these functions and subroutines in such a manner that they behave rather as a team. Okay, module helps that. What module does is it makes sure that all the functions and subroutines defined inside it behave like a team, behave as a part of a team. Okay, they become internal to it. And module is something like a program, but it needs a program to invoke it. Okay, now what I've done is that to make a module here, what you need is that you just have to define all your subroutines, functions, just like how you define normally. Okay, and what you have to do is to start a module, write the keyword module, and then write the module name. Okay, and then to ensure that you have written to indicate to the module compiler that this module has these files and all, this subroutine, this recursive function, and many others. You have to write the keyword contains, just like how you include an internal procedure in program by using the word contains and defining them. You have to define functions subroutines inside a module like this. Now there are a few notes here. I just wrote. Okay, if the functions are inside a module, then other functions and subroutines inside the module can access it easily. No external referencing is required. What I mean is, see, suppose if I did not write this module, let's say, okay, what will happen is that this subroutine cram needs this function. This subroutine cram needs detf function externally, has to use it. So I have to define this as real *id external double colon def to indicate that a definition for this variable or this function is outside subroutine. Okay, now the thing is, if I were to write this in a module, if I write this in a module, now all of these become a part of the same program. So I mean, so part of this become a part of the same script or a same group. So because of that, I don't need this anymore. I don't need this anymore. All right, that's one of the advantages you get if you write things as a module. Instead of all the files, all the subroutines and functions becoming external to each other, they become kind of internal to each other. So in the sense, one knows exactly where the definition of the other is and stuff, so you don't have to explicitly define an external keyword inside the functions and subroutines to make your life simple. Now in all of our programs, what we did is that we didn't define module and all to go ahead with this. Reason, because the number of subroutines we used and the number of functions we used were extremely small. So we never had the necessity to write modules, write the module. So we just go ahead. So we just wrote this external definition line in all the subroutines and functions which uses other functions and all, and we went on with it. But so imagine if you are working on a really serious project wherein you have to use, say, 30 functions or 40 functions and several other subroutines, and each subroutine uses 3 to 4 functions and all, okay, of different return types. If that being the case, writing such external statements for every function makes your life really hard to follow, really hard. Okay, and this is and whenever you compile, you'll just get so many errors just because the external definition has not been met with. Okay, now when this way things become really easy to follow. Things become really easy to follow, and that's why I wrote here. You don't need any external referencing needed inside the module for all the functions. Okay, at the same time, there's something you have to keep in mind regarding the name. The module name, this, and the file name need not be the same. This is the module name. I'm named it maths1, okay, and the file name is maths_mod, okay, but they need not be the same. But it is okay to be the same. In general, it's better you make it same. Okay, if the file name is different, meaning this is different from the module name, then the object file that you will get while compiling this file will have the file name. Okay, now if I compile this, the object file will be maths_mod.o, whereas the module file .mod file's name will be maths1.mod. Okay, and now when that being said, I have to use the .mod file's name inside the call, while .o file's name for building and execution. I'll explain you guys what I mean. I'll just open the shell script. Okay, I just open the shell script and see if I were to run this in the terminal, ls. Okay, this is what I get here. I didn't run this, I'll just explain you guys. This is the module, the file name is maths_mod.f95. When you compile this, okay, you will get an object file like this, maths_mod.o, and then you will get a module file called as maths1.mod. Alright, and now suppose if they were exactly the same, let's say, what you'll get is that both this .mod file and the .o file will have the same name. Okay, and when I were to refer this module inside the program, I should use the module name, this name, maths1, not this. If I were to include this will throw an error, but I have to include this. So for all practical purposes whatsoever, it's recommended to have the same name for module and the math. Alright, and now there is this one more thing you have to keep in mind. You can define a module inside the program itself, in the sense inside the program script itself. It's like this. You can copy all this. Okay, you can copy all this all the way from here. Copy all this. Okay, and you can define, if you're defining a module, it should be above the program. Now if I were to save this temporarily and compile this, this will not show me an error. But if I were to cut this up, did I delete this? No, good. Cut this up and put it at the bottom, save it, and then compile this. Surprisingly, it doesn't throw me an error. Maybe it's because the mod file has been still available. I'll just remove the mod. Okay. Now if I were to check, yeah, fine. Now if I were to compile this, it throws an error. Alright, because it says that match1.module is not available. Okay, since I've defined this here. But on the other hand, if I were to cut this and place it at the top, save this, if I were to compile this, it works fine. Now why is the discrepancy? See, this discrepancy is because this module, when this program is being executed here, it requires the module first to be available. Okay, now when you compile this, when this program gets compiled first, okay, this part of the program, the beginning part of it is the module, and this compiles first, and when this compiles, it produces the mod file. Okay, and then it goes to compile the program. Now when this order is followed, the match.1 module is available, so the program doesn't throw any error. Whereas if I were to place the module behind the program and execute this, the program will run first, and since the module part has not been compiled, okay, this match1.mod will not be available, so it will just throw an error stating that this is not present. Okay, similarly, okay, I can what I can do is that I can I can use the word contains and write the module inside the program itself, and for this I think I don't need this. Okay, anyway, I'll just delete the mod file here. That will be available here. Click ls, there will be a mod file here. Just remove the mod file. Okay, the mod file is not there. Okay, now if I were to compile this, okay, it throws me an error. Okay, unexpected module statement in contains section. Okay, I think this contains need not be there, I suppose. Unexpected module statement and contains. Okay, apparently you are not allowed to enter a module inside the program. Other than that, everything is fine. Okay, so this is something you have to keep in mind. I think you should not as per my understanding goes by, you are not allowed to write a module inside the program. But anyways, this is something you have to keep in mind. Okay, and there is this one more thing I have to tell you, regarding modules. This is done, and this is, what you have to do is that when you write a module in a separate file, like what we saw, what happens is that you have to compile the module file first, and then the file where you're invoking the module second. this order has to be mandatory. Okay, even if you are compiling multiple files together, the module files have to be compiled first, and then the programs that call the module has to be compiled later. And once these are compiled properly, okay, the order in which you compile the object files need not be the same. For instance, what I do is that I'll just remove this. Okay, remove this, and in terminal what I do, bash I just execute the shell file here. It works fine. The order doesn't matter as long as the object file is available. Object files are available, the order doesn't matter, because the compiler knows, okay, it'll merge these two, so it knows how to merge them and all, so it turns out to be fine. Alright, this is something you have to keep in mind. And then suppose if I were to cut this and place this here, and if I were to call the same Kramer's rule again, it will throw me an error, because it says that the max.1 file is not available. Because why? Because the module has not, because of this line the mod files were deleted. So that's the reason. Mod files were deleted, and simple as that. Now if I were to run this, it just works out fine, perfectly fine. And now there is just one more concept I have to tell you guys before I end this tutorial. Okay, there is this facility that functions can do when it's written in modules. Functions can return arrays when they're written inside modules, and I'll explain you guys how. This is a program wherein it calculates the factorial of 10 numbers, n equals 10. For 10 numbers, the numbers are stored in this line. I'm keeping an iterating variable I to save the value, and I'm allocating all the first 1 to n values with the value of I. So the numbers are from 1 to 10 here. Okay, and the num fact is actually the factorial of all these numbers. Is an array storing the factorial of all these numbers. Okay, and you may not what you have to keep in mind is that this fact here takes the number array and the total number of values in it, and then returns an array that will have the corresponding factorial of the numbers here into this fact, and then I'm using this do loop to print the values. To make this possible, what I've done is that I've used this I use this factorial program here, and I use fact1 to use that. And now here, if you notice, both the module name and the file name are the same, fact1. Now here I have defined this function over here inside this module. Now what does this do? This does is that this function will take the number and n. I am taking it as intent in. I'm taking this number as a dimension of size n and intent in, defining two iterative variables I, j, and defining an integer variable fact just for simplicity, and then I'm defining the function name as integer of type and dimension. Okay, usually we write the type of the data type of the function at the top. Here I'm writing the function definition, the function return data type, and then the size of the returning variable here inside the function. This again is allowed. Okay, that's one of the facilities that's one of the flexibilities available in Fortran. Okay, since I defined this, now by this I'm explicitly mentioning to the program that this function is actually an array that returns multiple values. Okay, and then what I do is that I just start a do loop, the same do loop mechanism we saw in one of our previous programs. I just start fact equals 1, fact equals 1. I iterate from I equals 1 to n, I equals 1 to n, and then I just I just start a second do loop which iterates from I equals 1 to the current number to be calculated, and then I set the fact equals 1 here, so this will just give me the factor. This will just calculate the factorial at the end of this looping segment, and then stores this fact value in the factorial of the given number. Okay, this do loop iterates n time. This outer loop iterates n times. Sorry, outer loop iterates n times, and thereby working out all the arithmetic and for factorial arithmetic for all the numbers, and then saves it to the fact num, and that value and this entire array gets returned. Sorry, this entire array gets returned here. Now if I were to let me just click ls. Let me remove all the files with mod, all the files with exe, and all the files with o. Yeah, perfect. Now I'll show you guys how this works. Suppose if I were to write this function, I'll just copy this. I close this, and now I don't need these. Okay, suppose I were to write all this function here, okay, and I don't use this use fact operation. Okay, if I were to compile this, it just throws an error stating that hold on. Hi guys, welcome back. I just got a call. Anyway, coming back, suppose if I were to define a function, copy the function here and write it here, and compile this, it will just throw me an error. Okay, it just says that fact num has no implicit none, there's a mismatch kind of a thing. Okay, it's possible because we didn't define this externally. Alright, now if I were to compile this, if I were to compile this, I still get an error. Okay, the external attribute conflicts with the dimension stuff. Okay, it just throws me main issue that there are some external dimension conflict and all. So okay, what I do is that suppose I just remove this dimension part of it. Okay, run this again. It's still showing me some problem stating that it's explicit interface required and stuff. Okay, now there's a simple way to do this. I'll just replace this as it is. Okay, there's a simple way to do this. This may not work most of the time, especially for this kind of a program. So what you can ask, if the array just a single returns just a single value, this external keyword and stuff will work out perfectly fine. But if it's dimension like this, it needs a little more treatment to work with. But a simple way is that there are two simple ways. One, use a module, write this entire function inside a module, and like this, and compile the module along the file, and you'll be okay with it. Or else there's another way. This is the first other way. What you can do is that I can just cut this and use contains and write this and make this function as a procedure within the program. Now if I were to compile this, it will work fine. If I were to build this and execute this, it will work out fine. See, it just works out fine. Okay, now this is something you have to keep in mind. Defining functions that return arrays are a bit tricky actually. All alone in this file, writing them may be erroneous, especially like that. Maybe erroneous. Sometimes it might work. I think there is a way to make it work like this, but I'm not sure as of now. If I find, I'll let you guys know. Okay, if you guys find any, you do let me know. I'll correct this and learn it also, and defining but if you were to define them as with external and dimension keyword like this may not help you properly. But the only solution is either define that function entirely within the program like this using the keywords so that the function becomes a internal procedure for the program, okay, like this, or define it in a module like this and use the module accordingly. Now if I were to remove this off, and I don't need this here. Now if I were to compile this, I have a fact sh file here, bash star dot sh. What it'll do is that it'll do the same operation. I'll just open the file for you guys. It just clears stuff, removes all the mod files, compiles the fact module first, then compiles the function second, and then generates the generate the object files, merges all the object files to produce an executable called as fact.exe, and then runs the executable. Now if you guys notice, it'll just remove all the object, it'll just list out, clears everything, listed all the files that are available. It removes all the object files, mod files, exe files. Since there aren't any here, it just shows an error, but if there are, it won't show like this, but no matter. It just lists all the files, then it compiles the first file and produces a mod file. Okay, if it compile a module, it produces a mod file and also an object file. Okay, it produces these two when comparing this, and then it produces an object file when compile this, and then it just merges these two to produce an executable file this. Okay, and then runs this, and the results are like this. Suppose if I were to change this to, say, let me not be a miser, just give it 20. Okay, and I run this again, it'll just work out fine. Okay, now this is how you define modules. And how to how do I say, and how to make functions that return multiple values simultaneously as an array. Okay, well, if you guys notice, this is exactly the way in which certain functions like cos function, sine function, and all, which took arrays, returns an array also. And if this is kind of the motivation behind how those functions are actually defined. Okay, now this tutorial is getting long, very long, and that's all. I don't have anything else to say for this tutorial. That's all I have for you guys in this tutorial. Okay, thank you guys for watching, and I'll see you guys in next tutorial. Do please subscribe to my channel. Bye.